We are often asked how much a plastic injection mold tool costs, and unfortunately the answer is always the same. However, we realize that's not very comforting when you're trying to calculate your expected upfront costs at the start of a new injection molding project. In this episode of Factory Insights, we thought it would be helpful to offer a few tips about what drives tooling costs and what you, as the product designer, can do to control and possibly lower them. The cost of a plastic injection mold tool is based on four main drivers: the tooling raw material, the size of the tool, the complexity of the tool design, and the time it takes to make it. Let's look at each of these a little more closely. First, we have tooling material. The tooling material cost is calculated by the volume of material consumed and its price per unit weight. Let's compare, for example, an aluminum tool against an equivalent tool made from P20 tool steel. Since the volume of material consumed is, of course, exactly the same, and aluminum is lighter than steel, that should mean that the aluminum tool is cheaper, right? Not so. Aluminum is more expensive per unit of weight, so the total dollar value works out to be about the same for the two. Instead, from a product developer's point of view, it's more important to ensure the tool material matches the plastic resin, since some resins can attack certain tool steels, especially if abrasive fillers like glass fibers are used. Our advice is not to try to save money by using a cheaper tool material, which always costs more in the end. Number two, tool size. This is fairly straightforward and is contingent on the size of the finished part, especially if the tool is a single cavity. A larger tool would consume more raw material, hence it's more expensive. But bear in mind, the size of the tool isn't always in direct proportion to the size of the finished part. It's also affected by any additional features that need to be added to the tool, like movable sliders or complex cooling channels. Extra features usually mean a larger tool to accommodate them. Number three, complexity. Complex tools require more expensive engineering and fabrication, and this is where the product designer can most directly influence the tool cost by keeping the design as simple as possible. Every additional design feature represents more fabrication costs, not only in the cavity but also for the runners and cooling channels and other accessories. This also includes tool treatments such as polishing or photo etching. Also, remember that engineering time, representing design and computer modeling, is more expensive than production time. Number four, tooling lead time. The time it takes to make a finished tool includes the initial design, computer modeling and mold flow analysis, rough machining, finishing, and testing. Again, simple designs are the easiest and fastest to make and therefore the least expensive. There are several online cost calculators that use various predictive models to generate fast and generic quotations for tooling costs. To do this, they all rely on simplified shapes made from standard resins where the molding parameters are well known. However, accurate and precise quotations should always be vetted by skilled human technicians who look at every design detail carefully and match it to the intended final application, something that an online calculator can't do. That's why we won't give a one-size-fits-all answer to the question of how much a tool costs. And we suggest that you don't trust anyone who says they can. There are too many variables, and each should be carefully taken into consideration if you want to make a quality product and not just a commodity. We hope this brief overview of tooling costs has given you useful advice about how to plan carefully for your next injection molding project. And if you have any further questions, we'll be happy to answer them in the comment section below. Please consider liking us, ding the bell, and subscribe for more factory insights from your friends at Star Rapid.